Hello, in this video, I'd like to evaluate the Redodo 3 kilowatt inverter charger. The setup is like a power wall. I call this the May-Flowerwall. And it has a battery inverter. So the first step is to turn on the battery. So let me turn on the battery. Okay, now the battery is turned on, and I like to take a look at the vitals of the battery. So this is the app. Sorry, the wrong app. This is the app. It's a JKBMS. It's good for 300 amps. And this is the condition of the battery now. The capacity is 525 amp hour, and it's 81% charged at this moment. So the next step is to turn on the inverter. It has to go through a sequence to make sure everything is working properly. So the sequence is the battery comes on first, and then the inverter comes on second, and then shore power last. When I shut it down, I reverse the sequence. I undo the shore power and then turn off the inverter before I turn off the battery. So let me turn on the inverter. The inverter is on now. Okay, the inverter is on, and as you can see, immediately the battery is providing 1.9 amp to power up the inverter. So this inverter overhead draw is pretty good. It's only 1.9 amp. It's pretty good. And next thing is we want to take a look at the waveform of the pure sine wave inverter. So I put in a couple of pins on the AC output to take a look at the waveform of the inverter. And I have a scope setup in here. So let me do auto. Okay, so this is the waveform of the inverter. It's a very nice pure sine wave. And the output voltage is 344 volt peak to peak. And if you convert that into RMS, it will be 172 volt RMS. And then you can convert that into the regular voltage. We can divide that by 1.414, and it should come out to be about a little over 120 volt. So it's quite powerful. It's go all the way to 120 volts. And the next step we want to do is to turn on some loads. And the load I have right now is I got a heater. This heater is probably 1500 watt. And then I also have a water kettle, which is about 1000 watt. So let me turn on the heater. The heater has two settings. This is the first setting. Okay, this is the fan that is turned on, and as you can see, it's drawing 58 amps, and the battery power providing 770 watt, roughly 730, 50, 760. So let me turn on the other part of the heater. Okay, I turned on the other part of the heater, and the fan on the inverter came on also to keep it cool. So now it's about 1500 watt, roughly 1500 watts. This is DC power, and the fan comes on 1500 watt. We could also take a look at the display. We could take a look at the output. This display is not very good. So we can tell now the battery is supplying the output. You see the battery with the arrow going through the inverter, and the load currently is about 25%. That's what it says. I don't believe it, but it bounces around between 25 and something higher. And let me go to a different screen. Another screen. And now the voltage is 113 volt because of the high low. Okay, so now we could turn on the water kettle and see how high a voltage, how high a voltage it will be. Okay, this is the cord to power up the heater, and here's the plug for the water kettle. And the kettle, oh I'm sorry, this plug is only good for 1 kilowatt, which is slightly higher than the water kettle usage. So let me do the water kettle. Turn this on. Okay, now the water kettle is also come on. Now the total wattage is 2600, roughly 2600. It bounced up and down a little bit, and the current draw is almost 200 amps. Now it's 200 amps. Negative is drawing current. Without a negative sign is charging. So this inverter definitely could provide at least 2600 watt, and I don't want to go any higher than that for reasons that I did not use the thickest possible cable. These are 1 arc cable, and 1 arc cable is probably reaching the limit at about 200 amps. And so now we tested out the maximum power. Let me turn off the water kettle. And next test I like to do is to do shore power plug-in. Now I go back to about 1500 watt. The reason I didn't want to do shore power with the water kettle on is because my socket is only good for 15 amps, and then I don't want to overload the socket as well as the cable here. So let me plug into shore power. Shore power. Okay, now the shore power is plugged in. We can go back and take a look. Now the current, instead of negative, actually start charging because the shore power bypass directly from the input to the output to power up the heater, and then the inverter has a 45 amp max charging current capacity. So right now it's charging the battery, and it worked as expected. So this is the waveform. This is mostly the utility waveform because we bypass the inverter. It goes from shore power directly to the heater. And let me undo the shore power to look at the waveform again. Okay, no more shore power right now. And the heater is using about 1500 watt, 115, 117 amp. And a sine wave is coming directly from the inverter itself, no longer the shore power sine wave. And the sine wave is extremely clean. So this is a pretty good inverter. It produces a very good sine wave. And let me share with you some of the safety features that the system I have in place. So first of all, let's take a look at the BMS safety feature. There's an overcharge protection, overcurrent protection, temperature protection, high and low temperature protection, and also drop protection. I don't suppose I would drop the BMS or the battery. And then over discharge protection, short circuit protection, GPS protection, under voltage protection. So this is the protection from the BMS. And the inverter has its own protection. It has the overload protection, over temperature protection, over voltage protection, low voltage protection, and output low short circuit protection. So there's quite a bit of protection in the system I have in place. And we could also take a look at the on-off and shut-off, AC power on-off, because in my setup I only use the AC power, no DC power. So physically there is a BMS on-off switch, which is this. This is the BMS physical on-off switch. And also have the BMS soft charge and discharge on-off switch. So in here I could turn the charge or discharge on-off. And then also have a 300 amp battery fuse. There is a 300 amp battery fuse in here. I will show the setup later on. And then there is a physical inverter on-off switch. So this is the inverter remote on-off. It has over priority than the physical on-off switch on the inverter itself. So in order for it to work properly, this switch has to be set to off, and then use the remote switch to turn the inverter on and off. And lastly, the last protection is the inverter input and output manual reset circuit breaker. So here we have two circuit breaker for the input and output AC reset in case something overload or something like that. So this is basically the test I wanted to do. Let me shut off the electricity, or at least shut off the heater first. So I just shut off the heater, and Okay, now the fan goes off. It appears that when the fan was on, it draws about 2.5 amp of parasitic or overhead. Now without the fan, it's drawing about 1.9 amp for the system. And so the fan is off. Let me move my scope away. And I'd like to talk about the arrangement and setup I have. So let me remove the cover first. Okay, the cover is removed. The system is pretty simple. So this is three cells in parallel, and then 4 cells in series. 4 group in series, I'm sorry. So this is a 3 parallel and 4 series. This is the negative terminal. The negative terminal go to the 300 amp BMS. And this is a new BMS that has the 300 amp current capacity. So as you can see, this one has a 3 terminal for the BMS, for the input, for the battery connection, and also 3 terminal for the output inverter connection. So that's the BMS connection, very simple. And then these are the balancing, cell balancing lead. It actually have a 2 amp to balance the cells, because that is the most critical aspect of a good BMS. It could do good balancing. And this is the 300 amp fuse. 300 amp fuse. Positive connection. So this is pretty much the connection for the battery. And this is the switch to turn on and off the battery. This is the LED. In a previous video, I showed you how to use an LED to pre-charge the big capacitor inside the inverter. So right now, the battery is charging the capacitor so that the LED is off. If I turn off everything and disconnect the wire, this LED would come on. And this is just a switch for me to power up the USB to charge my phone. This phone is pretty much dead. The battery is shot, so that's why I need to use a USB to keep it running. And I'm using it as my display. It works out pretty good. And this particular BMS has very, very nice cable locks. So some of them doesn't have the cable locks, and this would not keep it tight. With the cable locks, I soldered the wire onto the cable lock, and it would be very sturdy from there on. And let me show you the cost of doing this. Oh, before I show you the cost, I want to talk about the pros and cons of this system, or the, this inverter. So, number one, it has a 3 kilowatt. It's a compact design. It's a drop-in replacement for the 2 kilowatt inverter charger in a Hymer RV. So this is compact and that's 50% more power. And the idle current consumption is only 1.9 amp or 25 watt compared to 55 watt for most. It has 2 fans, push and pull. So this is a fan that pushes the cold air in, and this is the another fan to pull the hot air out. And so it's a very good cooling arrangement, and the cable lock for secure connection, and the remote control display. This display is not very useful, but it's good to show you know, the basic information, not a whole lot. And the design is very look very good quality and excellent value. This inverter is very reasonable. The cons, the eco mode does not work. So it comes with a eco mode. So eco mode is supposed to detect if there's a low. It would turn on the inverter. Unfortunately, it would detect and then it will shut off again. It will detect and shut off again. So this eco mode doesn't work. I tried different kinds of things to make sure that's the case, and it is. The other con is the charge current is only 45 amp. 45 amp is a lot for DC current, but if someone wants to use a DC air conditioner, 45 amp is not enough to power a DC air conditioner. And then the fan noise, because of the 2 fan, and the fan speed is pretty high, so it's pretty noisy. So next, let me show you the cost of the system. This system is a 6.72 kilowatt hour. I call that the May-Flowerwall. And this cart is 550 pounds. Very good value. This cart is very sturdy, extremely strong. And the JKBMS is $80. And then the inverter is $450 roughly. And I have a 25-foot 12-gauge extension cord for the input and output. So this is basically one extension cord, 25-foot. I cut it in the middle and use the plug for the input side and then use the socket for the output side. And good value. This is a 12-gauge extension cord. And then I have the rest is all free. The cells are free. The bus bars are free. The cables are free, and all the stuff I got it from my junk pile.